So I've been on a bit of a journey these past few years. It actually all started about a decade ago when I found this in my parents' house. It's the sound card from the first PC my family ever owned, an Ensoniq Soundscape Opus. I really wanted to get this sound card working again because I remembered it having a very unique sounding wavetable synthesizer in it. But because it's such an old sound card, I needed a computer that could run MS-DOS to be able to use it. And if you can believe it, at the time I didn't own any computers that could. So I started buying and building DOS gaming PCs, at first with slower processors like 386s and Pentiums, then moving on to more powerful stuff like Athlons and Pentium 3s, which are about as fast as you can go with consumer motherboards that can still run DOS properly. Then finally, I got into exotic industrial embedded motherboards, which let me run DOS on Pentium 4 and even Xeon processors. I'll link you to my videos below showing this whole journey from start to finish. But there is one question we've never answered. How far can we push this ridiculous experiment? Well, today we're going to answer that question by building the fastest DOS gaming PC that has ever existed and possibly will ever exist. Let's get started. This video is brought to you by PCBWay, who have kindly sponsored my channel for crikey, it's been 4 years now. PCBWay are a full-service PCB manufacturer and assembly house who have made literally hundreds of PCBs for me over the years and have yet to have a single thing go wrong with anything I've ever ordered from them. Even when I've made a mistake, and I make a lot of mistakes, they've always caught it and advised me before manufacturing, so they absolutely go above and beyond in their services. The company I work for in my day job have even switched to them for their manufacturing needs, and compared to the place we used to use, working with PCBWay has been an absolute dream. The best part of PCBWay, in my opinion, is the shared projects section. If you've ever struggled to figure out how to order one of my PCBs, for example my Hidman project, which is an open source device that lets you use modern keyboards and mice on retro PCs, the shared projects section makes this a literally 10-second process. Click Add to Cart, type the number of boards you need, hit Calculate and Save to Cart, and you're away. Full instructions are in my Hidman video, which I'll link to above and below. But PCBWay are not just a PCB manufacturer, they also do advanced 3D printing, CNC machining, injection molding, and sheet metal fabrication in every material and process you've ever heard of. And, if you can't design anything to save yourself, they'll even design your PCBs and other parts for you. Get in touch with PCBWay today, you won't be disappointed. Before we can build a DOS gaming PC, first we need to define what exactly a DOS gaming PC is and how it differs from a normal PC. Well, firstly, it has to run DOS on bare metal with no virtualization or emulation. DOSBox, PCM, 86box, etc. have made it far too easy to run DOS games on modern PCs. A true DOS gaming PC boots DOS and nothing else. Secondly, it should run most well-behaved DOS games. There was no PC that could run all DOS games, the most common example of this being older games that run unplayably fast on later PCs, but we expect to be able to run a decent cross-section of DOS games that are known not to be too picky about hardware. Finally, and most crucially, it has to have full audio support. As I've said many times on this channel, the biggest hurdle to vintage DOS gaming is support for sound cards. Virtually every DOS game requires a Sound Blaster compatible sound card, and Sound Blaster compatible cards can only be plugged into ISA slots, which are the slots that were present on the first ever PC, the IBM 5150. There are software solutions for this, most notably Crazy's SBEMU, which is a very cool piece of software, but that would violate Rule 1, no virtualization or emulation, so we need a computer with an ISA slot. The trouble is, ISA slots haven't been present on consumer-grade motherboards for over 20 years now. There are exotic industrial motherboards with ISA slots. The fastest motherboard with a proper ISA slot that I'm aware of is this Ruby 9719 VGAR motherboard from Portwell, which can take Socket 775 processors. With a bit of hacking, you can install a Socket 771 Intel Xeon X5470 3GHz in it, which is ludicrously fast in DOS terms, but it's still a 16-year-old processor. We need to go deeper. Regular viewers of my channel will remember Project Disappointment, which is a device that can activate the vestigial ISA bus that exists inside basically every motherboard. You connect it to the TPM or LPC debug port, which is normally used for encryption modules, and it gives you a mostly functional ISA slot, certainly good enough to run a sound card. In my video about it, I tested Socket 1155 motherboards with Sandy Bridge and Ivy Bridge CPUs, but they're still over a decade old. So I got to thinking, what's the furthest we can push this ridiculous experiment? The trick with the ISA slot unfortunately stopped working with the introduction of the Intel 100 series chipset. Theoretically, the last Intel chipset to support proper ISA DMA was the X99 chipset, so we'd be looking at socket 2011 processors. These are mainly aimed at servers and high-end workstations, so as well as the hardware still being kind of expensive, the processors aren't exactly suited to DOS gaming, as they're optimized for parallel processing. As there were no multiprocessor-aware DOS games, if you know differently then please let me know, we really want a processor with good single-thread performance. So I hit up CPUbenchmark.net and tried to find the fastest single-thread processor that runs on a pre-100 series chipset. It looks like the sweet spot is socket 1150, specifically the Haswell-based Core i7 4790K at 4 GHz. So I grabbed one of those on eBay. Next step, find a suitable motherboard. Luckily, it turns out I already had an ideal one lying around, this DFI HD100 based on the H81 chipset. I bought it on a whim a few years ago thinking it would make a good media center motherboard, but I never got around to building one. It's actually quite an interesting board, being mainly aimed at the industrial embedded market. It's mini ITX, so it leaves plenty of room in an ATX case for the ISA adapter board. It has an LPC debug port, which we need for the ISA adapter, and DFI were happy to send me the pinout for it. And as well as a full-size PCI Express slot for the graphics card, it also has a mini PCIe slot, which, spoiler alert, we'll take advantage of later. The only issue with this board is that the LPC port doesn't have an LDRQ signal, which is vital for the DMA support that soundcards need. Even worse, DFI wouldn't tell me if there was somewhere else I could access the LDRQ signal on the motherboard, so we need to find the LDRQ signal ourselves. The H81 chipset this motherboard uses actually has two LDRQ ports, numbered 0 and 1. LDRQ 0 is connected to the Super I/O chip, which handles stuff like the serial and parallel ports. We could disconnect it from the Super I/O chip and connect it to the ISA adapter instead, but that means we'd lose some functionality, so it's best to use LDRQ1 if we possibly can. But how to find LDRQ1? Well, according to the H81 chipset datasheet, the LDRQ1 signal is shared with another function called GPIO23. This is a general-purpose input-output port that can be controlled by software. So if we can rig GPIO23 to output a signal, say a square wave, we might be able to find it by probing various points on the motherboard with an oscilloscope. So I very quickly hacked up LSS4's LPC EXP utility to toggle GPIO23 at about 15 Hz, and with the motherboard switched on, started randomly jamming my oscilloscope probe onto random vias and test points. After a few sketchy minutes, I found the signal on a via hole on the underside of the board. Success! So, with all the research done, let's get started building this PC. First thing to do is prepare the motherboard. In many pictures of this board online, the LPC debug port is populated with a pin header, but on my particular example the pin header is missing. Adding a pin header is no problem, and in fact that's what I did at first, but I noticed that it blocks access to the mini PCIe port. Spoiler alert, I have plans for that port, so instead I decided to solder some ribbon cable to the LPC debug pins instead. This means I can route the cable underneath where the PCIe card sits and attach it to a pin header elsewhere. And because the pinout is different from what the ISA adapter expects, I had to make up a little adapter cable. I also had to solder some very thin wire to the LDRQ via at the bottom of the motherboard and route it to the ribbon cable too. For the case, I'm going to be using this appropriately naff looking one that I bought a while ago from my mate Doug. In goes the motherboard, which looks tiny in this ATX case. Next goes the ISA adapter, which has the holes drilled in appropriate places for mini ITX and micro ATX motherboards. Now the sound card. I'm going to use this ALS100 based one because it seems to behave better with modern PCs than the Sound Blaster I'd probably typically use. Then power. Because ISA slots need so many different voltages, and I'm a very lazy man, I'd just put an ATX power connector on it rather than a bunch of voltage regulators. This means we need an ATX power splitter to be able to connect both it and the motherboard to the PSU. Now in terms of graphics cards, I can pretty much use any PCI Express graphics card, but counterintuitively older cards sometimes seem to perform better than newer ones. When I was testing a previous motherboard in DOS, this turned out to be the fastest card I could find in my collection. It's a NVIDIA 7600 GT, so I think this card just has better support for DOS screen resolutions than cards that came out, 10, 15 years later. The other reason I want to choose this card is I have had some success in running the 7000 series chipset in other Windows 98 PCs, so this might be able to do as a passable Windows 98 gaming PC as well, but that's obviously not the priority. Okay, last thing to do is power supply, and I bought this very, very high quality reputable one from Amazon. I'm sure it'll be fine. It is not weigh very much, and it is claiming to be a 750 watt power supply. I very much doubt that's true, but we probably only need about 100 watts, so that's probably okay. The cables are also suspiciously thin. These do not feel like they're going to carry much current. And finally, I suppose, a hard drive. I'm going to put in just this crappy 128 gigabyte SSD, which I'm sure will be more than adequate. Just sort of stuff it in the corner here. That'll be fine. Next thing we need to do is install an operating system, and for powerful DOS computers like this I like to put on Windows 98 because it has FAT32 support, which means it supports really big hard drives, but it also has a very high degree of compatibility with older DOS programs. Now normally I'd install Windows 98 manually, but I thought I'd try something different today. This is a USB stick with a piece of software called Win98 Quick Install in it, and it is apparently a sort of distribution of Windows 98 that installs extremely quickly, so that should be interesting. Let's see if it works. Well, something's happening. I think it initially boots into Linux to do all this. So yeah, this it's all very good. Minimum 486SX with 24 megabytes of RAM. Can't imagine there were many 486SXs with 24 megabytes of RAM. Also, the minimum requirement for Windows 98 is 16 megabytes, so this isn't going to work for every PC. But we have 2 gigabytes, so I think that's probably all right. Well, is that it? Wow. Okay. All right, that certainly was quick. We don't have the graphics drivers installed, but okay, that is officially the quickest I've ever gotten to the Windows 98 desktop. All right, that's great and all, but we're really here for DOS, not Windows. So I'm going to set it up so that it boots into DOS by default rather than booting Windows. Just set boot GUI to 0. Brilliant. Now if we reboot, it should just go straight into DOS. Beautiful. It's even got some of the late great Rudolph Lowe's extensions. Alright, moment of truth. Let's see if the sound card works. First of all, we've got to use this utility called Safisa that I wrote that initializes the ISA adapter board. Okay, it detected the board. That's great. So everything must be wired up correctly. Let's see if we detect the sound card. I'm going to use the Unisound driver to initialize it. Oh, look at that. Okay, brilliant. I suppose the next thing to do is see if Doom's going to work. I think it said RQ5 DMA1. Oh, we've got music. No sound effects though. I think I might try a different IRQ. Let's try 7, RQ7. D1. Yay! Everything works. Oh yeah, there's more down here, isn't there? That's about the worst I've ever played Doom. Let's try that again just to redeem myself. Yeah. Alright, I think Doom works. Alright, we have a ISA sound card running in a practically modern computer. Isn't that great? Before we do anything else, let's maybe run some benchmarks. Now, in order to see how fast this supposedly fastest ever DOS PC is, I'm going to need something to compare it to, and this is the motherboard for my previous fastest ever DOS PC. It's the Portwell Ruby 9719 VGA-R or whatever it is, which I think is the fastest motherboard you can buy off the shelf that has an ISA slot in it. So I think this seems like the most fair thing to compare our new PC to. Now, I've run it through Phil's Computer Labs benchmark pack, which is a compilation of different benchmarks for DOS. Now, a lot of them just either don't work or don't make any sense for a computer this fast, so I've narrowed it down to just the ones that kind of make sense. And I've also added one of my own, the DOS version of Quake 2, which seems to be fairly CPU bound as well. Yeah, this basically gives us a baseline, and hopefully we can beat these by quite a lot. So yeah, let's run it on the fastest ever DOS gaming PC, and hopefully we get a significant improvement. Okay, results are in, and they're somewhat perplexing and a little discouraging, to be honest. Supposedly fastest, put that in quotes, fastest ever DOS PC is not significantly faster, and in fact slower in several of the benchmarks. Sometimes significantly so. I mean, that's maybe because we're using the same graphics card and it's limited by the graphics card, but SpeedSys, which is more of a measure of the CPU than I think the graphics card, gets significantly less on the supposedly fastest PC, so I guess that means that the CPU itself must be running DOS applications slower. Now, just as a sort of sanity check, I booted up into Linux and ran ran sysbench, and that's giving a lot more sensible results. Like we get 6864 for the Ruby and 7234 for the fastest PC. So the processor definitely can execute code faster when it wants to, but for whatever reason in DOS it isn't. Now it can't be because modern processors don't run real mode code very well, because I think all of these tests run in protected mode, that's 32-bit. The only other possibility I can think of is that DOS lacks the sort of, I don't know, Intel speed step or whatever drivers necessary to make the processor go at its fastest clock rate. Now I've had a look through the BIOS of the DFI motherboard, and it has very few options for stuff like CPU speed control or anything like that. You can turn on and off hyperthreading and stuff like that, but it doesn't have anything to control the clock rate. And the interfaces for these things tend to be quite arcane, so I don't fancy my chances of writing a DOS driver for speed step. So the only solution I can really think of is maybe try hacking the BIOS? It was at this point that I messed up. You see, DFI were kind enough to put the BIOS chip in a little socket, so to save some time I thought I'd just pull the chip out and read it in my handy-dandy ROM reader. Unfortunately, while opening the socket, I managed to rip it completely off the board, complete with all its pads, so I couldn't just solder it back. Oh, for f***'s sake. So I had to solder the socket to a little board, then attach it to the motherboard with a bunch of wires and hot glue. I didn't really record any of this because I couldn't be bothered editing out all the swear words. Luckily, after this ridiculous faff, the motherboard was fine again, so I could finally remove the chip from the socket and have a look at the ROM. Now, the BIOS is an AMI BIOS, which means it can be edited with a program called AMI BCP. This lets you edit which options are available in the setup screen, as well as their default values. And wouldn't you know it, there's an option called Boot Performance Mode, which doesn't normally appear in the setup screen, and is set to non-turbo by default. To make it appear in setup, we just have to set its access to user, but I'll also make it use turbo performance by default, so I shouldn't even have to change it. So after reprogramming the ROM and getting into setup, you can see that we now have the previously hidden option, and that it's set to turbo performance by default. Now, hopefully we'll get the performance we expect out of this thing. Let's get benchmarking. Alright, now we're cooking with gas. These numbers make a lot more sense for a supposedly much faster PC. The DFI motherboard is now beating the Ruby in every single benchmark, which is, you know, what you'd expect to happen, really. So yeah, the reason it was underperforming before must have been entirely because of the BIOS throttling the CPU slightly. So that's good to know. Had to do a bit of a diversion to get the BIOS working, but it was all worth it in the end. Excellent. I'm especially pleased with the Quake and Quake 2 results, because I assumed that these would be more sort of graphics processor limited because of how similar the results we got between the first and second runs, but now that we've unlimited the CPU, all of these are performing much quicker, and actually these are the best results I've ever seen for Quake under DOS. So yeah, I guess that's the challenge now. If you have a computer with a working ISA sound card in it that can beat these results, then no you don't, I don't believe you. Alright, I know this is supposed to be a DOS gaming PC, but I'm very interested to see if it's a good Windows 98 gaming PC as well. So let's go back into Windows. Holy crap, it certainly boots Windows quickly, doesn't it? Starting to like this Windows 98 quick install thing. But anyway, yeah, there is a hacked GeForce 7000 series driver available. I'll give you a link to it below. That should work on Windows 98, so could it be as simple as that? Well, mixed results. Alright, let's see if it'll go up to the native resolution of this monitor. Oh dear, oh dear. Yeah, here we go. For some reason the mouse has stopped working too. Okay, after a reboot that seems to work fine. We seem to be in 1280 by 1024 32-bit color, so that's pretty good. Now I suppose check the sound card works. It's certainly showing up in Device Manager. Let's maybe play a song so we can hear if it's going to work. Oh, Windows 98 Quick Install doesn't install passport.mid, for shame. Alright, let's just keep playing the Microsoft sound over and over again. Alright, yeah, that works. Alright. This is running very, very well, I think. Oh yeah, the bio rifle, my favourite weapon. Oh yeah, flat cannon, my favourite weapon. Woohoo! The shock rifle. There's the alternate firework on this again. Man, it has been so long since I've had a good game of this. And it is running very smoothly. Now, if you'll remember, I hinted earlier that I might have a use for this spare mini PCI Express slot down here, and you might be aware that you can actually buy extenders that will convert the mini PCI Express slot to a full PCI Express slot. Now, you might be thinking, what use is that in a retro PC? Well, I have other plans. You see, you can, instead of converting it to a PCI Express slot, convert it to, well, in this case, 2 normal PCI slots. And that opens up quite a few possibilities for retro fun times. Let's start by inserting the adapter into the slot. It's got little plastic tabs that keep it down, so that's handy. No screws required. And as you can see, the cable for the ISA adapter just sort of threads underneath the adapter and doesn't get in the way at all. So that's pretty good. I suppose I could have cut it down to the smaller size, but nah. And then it connects to the other board with a USB 3 mini USB cable, which is a bit unusual. It doesn't actually send USB signals over it, but it just so happens that USB 3 cables have the correct number of balanced lines with the right impedance to be able to send PCI Express signals. It's just a convenient use of that type of cable. And obviously the mini connector means that it can be small enough to fit on a little PCI Express card. I should have maybe plugged this in before I put the card in. Slightly awkward. There we go. And at the other end we put this PCI adapter. So yeah, but what cards are we going to put in it? One of the ones I want to put in is this network card. I want to be able to try DOS and Windows 98 networking, and I think this Realtek, was it RTL 8029? I think that should have drivers for both Windows 98 and DOS, so it's not a bad choice. The motherboard has a built-in Ethernet controller, but that's definitely not going to be supported by Windows 98 or DOS. And as for the other card, well, I think you can probably imagine where I'm going to go with this. Of course, I'm going to stick a Voodoo 3D accelerator in it. Like, a better choice for this powerful a PC might have been a Voodoo 3 or 4 or 5, but I don't own any of them, so a Voodoo 2 it's got to be. Now, because this USB port needs to stick out, it doesn't quite fit against the side of the ISA adapter board, so I might have to put this PCI adapter here near the motherboard, and the USB cable here is significantly encroaching on the motherboard. Will the graphics card fit in around that? Oh, maybe there's kind of a space. Oh yeah, it just fits. Oh god. Oh dear, I thought we were in trouble there. Alright, cool, no that's good. And then I think the ISA adapter board should be able to fit in the bottom slot. Oh yeah, there's just enough space. Okay, I've just about managed to cram everything in as far as I can tell. I have my doubts as to whether this ridiculous setup is actually going to work, but let's see. Try some DOS 3DFX Voodoo accelerated titles. Yeah, this is 3D accelerated, alright. Excellent. Cool. So we also have support for 3DFX Glide games, which is really cool. So this is basically a computer that can play anything. Actually, I wonder how the frame rate compares between this and the software renderer. A fair bit slower, it looks like. That's probably not too surprising because the Voodoo 2 is rather an older card. 39.3, so that's a good bit slower. It goes to show you the processor in this is so powerful it can even software render quicker than a Voodoo can hardware render. Now, I also compiled a version of Mario 64 that runs on DOS and should also support the 3DFX card. Oh dear. Yeah, this happened last time as well. I think I accidentally compiled it with the racism option enabled. But yeah, this is Mario 64, okay. But yeah, this is running very nicely with full 3D acceleration under DOS. So that's nice. I'm not going to play through it very far though because A, I'm not the world's biggest fan of Mario 64. B, if I was, I'd probably want to play it on the N64. And even if I was playing it on PC, I wouldn't be playing it in DOS on a Voodoo 2. I think I'd probably play one of the Windows ports. Let's try the 3DFX in Windows. Maybe compare it to how well Unreal did on the GeForce 7600. Change the render to 3DFX Glide for Windows. So it should use the 3DFX card now. So we'll see how that compares with the much faster GeForce 7600. It seems to be running at a less frame rate than it was last time. I'm also getting a lot of visual distortion, it looks like. That's very strange. I know that the graphics signal emitted by some of these Voodoo cards isn't exactly 100% normal. And I think we'll probably be limited to a resolution of 800 by 600. Yeah, it won't let me do any higher than 800 by 600. So yeah, as well as being able to play Unreal Tournament on GeForce 7600 in fantastic detail, I can also play it on the Voodoo 2 in much worse detail. But you know, that's fun, isn't it? So yeah, 3D effects acceleration fully working. Let's just check that the network card has come up. Oh yeah, it's detected it. I didn't have to install any drivers or anything, so I guess either Windows 98 Quick Install included them or they just come with Windows 98. So I think it was WinIPCFG. Oh, look at that. It's even got a DHCP address. Encouraging. In that case, can I just do like pinggoogle.com? Oh, look at that. I think we're on the internet. I'm not sure how safe it is to connect a Windows 98 machine to the internet, but I wonder what version of Internet Explorer this is. I'm guessing IE5. Alright, so how much of the internet is still going to work? Guessing Google won't. Oh, look at that. That's Google actually kind of worked. Latest web browser for Windows. Well, I'm getting search results. I don't imagine I can browse to any of these websites though. Nah, because I won't have certificates for any HTTPS sites. Basically, every modern website uses HTTPS, so none of this is going to work. And just to prove that this is a modern PC, I'm installing Windows 11. Got to do the old registry bypass trick because I don't have a TPM in this machine because I'm using the TPM slot for other nefarious purposes. Alright, here is Windows 11. I'm going to switch to capture card for this, so I'll probably just comp this into my monitor later. In fact, my monitor is 4x3, so we'll just fix that. And you can see it's a full working desktop. I've got, YouTube, whatever you want. So I have a problem. Yeah, you're telling me. So I can browse the web, I don't know, what else do you do in Windows? Say, start up calculator, I don't know, so yeah, full Windows 11. And actually, very usefully, I can even browse to the Windows 98 drive, which has all our DOS games and stuff. So I can download Windows 98 or DOS games from like GOG.com or whatever on this using modern Windows 11, and then all I have to do is restart and just go boot override, and I'm in DOS. Isn't that great? Or if I really want to set up a boot menu, I can go into Windows 98. And yeah, I'm in Windows. I've got everything I want in Windows, like, also calculator. Brilliant. Then with just a quick reboot, we can be back in Windows 11 again, and playing, whatever the latest AAA game is. Yeah. B, I did better than that. Alright, I think that's enough for one video, but I'm sure there are loads more crazy experiments we could try with this ridiculous PC. So if you have any hardware or software you'd like to see me try on it, then please leave me a comment and I'll maybe make a follow-up video. Especially I'd like to hear if you know of any DOS games that can push the limits of this machine. I've already tried many of the usual suspects. For example, Grand Prix 2 is limited to around 25 frames per second, so it's already maxed out. The frame rate in build engine games like Shadow Warrior and Redneck Rampage seem to be limited by the graphics card rather than the processor, so I'm getting pretty much identical results as in older motherboards. I've even tried running Ion Fury through the DOS port of eDuke 32, but I couldn't get it to run on any of my DOS PCs, let alone this mental thing. Now, I'm sure many of you are thinking, how can I build a machine like this myself? Well, I really wouldn't recommend it unless you're a fan of pain, suffering and frustration. PCs like this just don't want to exist, and I've had to buy over a dozen motherboards just to find one that did everything I needed. I even destroyed 3 of them in the process, admittedly one of those was deliberate. I certainly don't know of any motherboards that can be used without extensive modification, and even if you did find one, what's the end result? A computer that's too fast for old games and too slow for new games. So if you're a fan of actually playing games, then this probably isn't the PC for you. No, the real value of this PC, in my opinion, is to celebrate the history of the PC itself. It's simply astonishing that an essentially modern PC capable of running Windows 11 is also compatible with some of the same hardware and software as the first ever IBM PC, which was released nearly 45 years ago. I think there's something almost magical about that. In fact, just as one final experiment, let's try that. Here's my IBM 5150, the first PC ever made, which was kindly donated to me by a lovely chap called Clinton. Into the 5150 I've installed a Sound Blaster 16 sound card, and as you can see, or rather hear, we have full music and sound effects in Commander Keen 4. Now, I'm just going to take the sound card out of it and put it straight into our essentially modern PC. And as you can hear, it works every bit as well as it did in a PC made over 40 years before. The only other place you'll find that kind of backwards compatibility is in the mainframe market, where I'm sure there must be 60-year-old COBOL code running in the depths of a bank somewhere. If you do, however, fancy getting into the world of overpowered DOS PCs, but don't want to spend months debugging endless problems, I recommend building something like my RetroRocket PC, which is based around the still widely available Athlon XP processor, and it works absolutely wonderfully. I'll give you a link to my video about it below. It's a great PC that I use all the time for both retro gaming and random experiments, and I think everyone should build themselves a RetroRocket. But I suppose we should address the burning question on everyone's mind. Is it possible to build an even faster DOS gaming PC than the one we built today? Well, I suppose the trivial answer is yes, we could always just overclock the processor and get it a few percent faster that way. But as I said earlier, if we truly want to take this crazy experiment further, we're gonna have to look somewhere else than Intel, as the 100 series chipset dropped support for proper ISA DMA. AMD chipsets, on the other hand, appear to have kept ISA DMA all the way up to socket AM4, which theoretically means we might be able to build an even faster DOS PC using a Ryzen 5000 series CPU. Unfortunately, despite 2 years of tinkering, myself plus some others on the Vogons forum have been unable to get any to work. There's some sort of filter blocking certain I/O addresses from reaching the LPC bus, possibly because of something like PCI subtractive decoding. If I have any chipset wizards in my audience who might be able to help, then please get in touch. For now though, please like, subscribe, comment, etc. and let me know if you want to see more experiments with this mongrel of a PC. Thanks very much for watching, and I hope you have a great day. Bye bye.